we will be discussing about like the Hadoop overview, like how the data will be stored in HDFS and how you will be processing those data using Yarn, MapReduce, and Spark. And also you will deal with data processing and analysis by using Pig, Hive, and Impala, which is very important in our course. And also we will be covering the concepts like data integration by using Sqoop tool. And basically the Sqoop, Hive, Pig, Impala, everything are the part of the Hadoop ecosystems. And by using the Sqoop, basically if you want to transfer the data from RDBMS to the HDFS file system, we will be using the Sqoop, and vice versa. While we will transfer the data from HDFS file system to RDBMS. So this is the purpose of the Sqoop. We will be will go deeper insights into the Sqoop as well in the further classes, and we will be discussing about the Pig. Pig, as I said, is very important to process and analyze the data by using the Pig. So in Pig, you will be covering like what is a Pig, what is its features, and the Pig use cases, and how you will be interacting with Pig. So basically, in our class, it is like for every session or every module, you will be having a theoretical session of 30 minutes and a practical session of 30 minutes, so that it would be very useful for you guys to understand the concept and implement the concept as it is. So like let's say an example, its first concept is like basic data analysis with Pig. So let's say the syntaxes of the Pig, how you are going to load the data, what are the data types, what are the field definitions, what is the data output, input, how you can view the schema, how you can filter the schema and sorting the data, something stuff like that. So by end of this course, like course in the sense this basic data analysis Pig. So I will be providing you the Cloudera distribution VMware, which is very important for this course. So it has inbuilt all the ecosystem tools together in one place. And what all you need to do is you just need to install it by using the VM player, and you can play with that. I will be providing the one project which covers all the concepts individually, and together you can make it as a big project. So basically, this is analytic project where we can use this as further reference also. So like by the end of this basic data analysis with Pig, I will ask you to do practical session by using these concepts. So likewise, in every module, like processing complex data with Pig, one by one we will go, and I will tell you the theoretical explanation first half session, and another half session you need to have a practical session. That only you will come to know the concepts. So like that, the multi-data set operation with Pig, you have the Pig troubleshooting and optimization. So likewise, we will cover all the topics in Pig, Hive, as well as MapReduce. So for every concept, we will definitely have a practical session. So this is all about the course curriculum, and by end of this course, you will be very confident on the Hadoop and its ecosystems, and as well as it will cover our the Hadoop administration as well. Like in Hadoop administration, you will be able to install a single node cluster, and you will be able to install multi-node cluster, and you can do everything with respect to the administration as well. So this is the added advantage which we are providing in this course at the end of this course. So here Hadoop, this is all about my course curriculum. So let me go technically. And also I would like to tell you guys that see, most of the in present environment, most of the systems are moving to Hadoop HDFS or Hadoop environment, because the huge because of generating the huge amount of data in their systems. Let's say, especially when it comes to the banking or e-commerce or telecom domain, you know how many applications are running for a bank or for a IT industry or for a e-commerce systems, and most of the data they need and they want to utilize that one to analyze it and to provide some meaningful data to the users. Uh, so in present environment, you know the value of the data, how it plays uh, a big role in their markets. So that's why most of the companies are migrating their systems to the Hadoop environment. Since the main basic two reasons is you can process the huge amount of data within the time, and you can accommodate the huge amount of data with low commodity hardware. So HDFS, this is all about the usages, why we need and all Hadoop. So when we go to the HDFS architecture, so HDFS in a sense, it is Hadoop distributed file system. So the files, distributed file system is to store a large amount of data on commodity hard disks. Like I said, so we will be having a huge amount of data sets, and we need to process it with low commodity hardware, means cheap hardware, like our systems. So Hadoop is basically like it's a cluster we call. So cluster in the sense grouping of small machines together in one place and play with it. Like if you have, we together have a sound systems, including my system, and if you configure all these systems using the framework and place it here and process the data parallelly in a distributed manner. So that's simplex. That is how the cluster will form. So inside this cluster, it is like each machine is called a node. So a node represents the physical storage of a data. So typically, if you have 7 machines, it's called a 7 machine node. And one will be having a master node, which will control all other data nodes. So a master node will have like the metadata entry. Like let's suppose I'm a client which is coming to this S7 group of uh, cluster and asking to load one file into HDFS into this one cluster. So what my master node will do is, let's say I'm the master node, and when the client is asking, so I will collect the information from the client and I will store this particular amount of data into these 7 nodes, and the data node will have its physical storage, but it will not have any reference. But when it comes to master node, I will have all my references with respect to the data nodes. Let's say Sqoop system or 70 system. So so the client doesn't know, and that means where the data is presented or where to store this data. But my master node, what we will do is during the configuration or while loading or processing the data, so I will have its metadata entry, where the system is located and what is this entry path. Let's say physically, when it comes to the file system, it is just like a path where it is presented. So all those paths and metadata entries will be presented in master node. So this is the basic advantages with the master and data nodes. So as I said, HDFS architecture, it is like a master and slave architecture. Let's say if I get a request, I will have that request and allocate those resources to my slaves, and it will my slaves will process the data and return back that information to my master. So my master will does the remaining work to my client. So HDFS cluster mainly consists of like a name node, a number of data nodes. Like I said, name node here it is a master node. That's it. My computer, this is called a master node, and all your computers are called data nodes. So all together forming in one cluster. Let's say zooming. This is how it is gathered all of this. So likewise, we call zooming as a cluster. So this is all about name node and data nodes. When it comes to the architecture, this is how the architecture will be. And here this is my client, and this is my name node, and these are my data nodes. So basically, when a file is when a client is requested to process one set of data or one file into my HDFS, basically it will process like first it will contact the name node. So what we'll do is a name node will have all its metadata entries like the folder structure of the data nodes, where this data is, where this block is present. So first the file will be splitted into blocks of data. Let's say my file is of 10 GB or let's say 100 MB. So it will be split into an equal number of parts. How it will split? It has its own mechanism to split the whole file into a number of blocks, and each block will represent some amount of space. Let's say 30, 50, 60, like that. It depends upon the configuration how you set. Like that, the file will be split into blocks, and each blocks will be stored across the data nodes. Let's say I have one file, one employee details file. It is of 100 MB. So before it goes to the data nodes, what the name node will do is it will split that employee file into 3 blocks. Each will have 30 MB of size. So basically, the HDFS, the Hadoop, we have an advantage of like a fault tolerance. So why fault tolerance concept is there is this one block of data will be stored in 3 times. Let's say one block 30 MB that will be stored across the nodes in 3 times. If while retrieving the data, if any one of the block is failed or any one of the data node is failed, so I can have an option to retrieve the block of data from the remaining data nodes to other data nodes. So really by default, as per the configuration, each block will be stored in 3 times. It's a replication. So like I said, if you want to process a file, it is asked to process a file into your HDFS. How it will deal? Like the file will come to this name node, and it will have its own mechanism to split the incoming file into blocks of data. Like depends upon the configuration you set. By default, it is like 64 or 128 MB. In our case, in example, we can set like 30 MB each. Each block is of 30 MB. So this particular employee file will split into 30 MB each block. And Hadoop has a mechanism called replication vector, where a data will be stored in 3 like block 1, block 2, block 3. So these 3 blocks of same data will be presented across the nodes. Let's say that we are like 6 nodes, one is master node and remaining 5 are data nodes. And this first part of 30 MB data will be stored into 3 data nodes, into 3 ways. Like this one is a data node 1, this one is a data node 2, this is data node 3, data node 4, data node 5. And these green marks are there, right, are called the blocks. See, the first block might be presented either in the data node 1 or in data node 2 or in data node 3, 4 or 5. Like that, 3 replications will be presented across the nodes. So why we need 3 replication vectors here? Yes, correct. So if something fails while retrieving data or while storing the data, you will not be recovered the data, right? If one of the machine is failed, let's say your Raghu's machine is failed, where my first block of data is stored. So while retrieving it, my data will be lost. So I cannot give my 100% assurance about my data. So if you have this factor, like the storing of data into 3 areas, even if robust systems is failed, still I have that block of data in others like Sussex or 70 system or data node or nation. So I can retrieve that data, or I can process the data from the other nodes, other data nodes. So that is the advantage which we have in HDFS. So and accordingly and similarly, we can process this data in parallel mode. So like it's not like a sequence, one has to complete and give a handshake to the other, and one other node has to wait. It is not like that. So we can process the huge amount of data parallelly. Like first block of data, it is 30 MB, second block 30 MB, third block of 50 MB. How much time that 30 MB block of memory is occupied or taken, the same will be taken for the 3. Let's say in earlier systems, it is like in a sequence systems, if you want to process 100 MB of data, you need like it is divided into three ways, 3 parts. Each will take 10 minutes. Together it is called 30 minutes to process this 100 MB. By using this distributed parallel mechanism, you can use the same 10 minutes for all the 3 blocks. So how much time the first block is taking to process the data, similarly the second block will take, but it will happen parallelly. So the final result indicates you have processed the data within the meantime. So that is the advantage with the distributed file systems. So Hadoop is part of this distributed file system. So this is all about the name node. So let's say one of my client is coming again and asking to retrieve some meaningful information which is there already in HDFS. First, what will happen is a client will request the name node, and the name node will have all our blocks of data information with it. That is called the metadata. It has the name of the block, it has the replicas where and all it is presented, and it has the path, physically where it is located in our cluster. So first what we'll do is suppose if I want to retrieve the second block of data in the employee file, which we processed at the first step. Now I want to retrieve the second step. So the client will contact the name node, and the name node knows where my data is presented across the nodes. So accordingly, I can start the process to retrieve that information from the data nodes. Like that. So the replica factor also will be useful. While processing the data from my name node to data nodes, if any one of the system got crashed or failed or any network connectivity issues, so it has its mechanism to send the heartbeats to the name node about the status in every sessions. So my name node will come to know what happened. If I retrieve the data successfully, then fine. If I'm not able to retrieve the data, then it will allocate the other resources to retrieve the data from the other data nodes, which is of same data presented in second block replica. Still, if it fails, again we have one more block. So depending upon your system failure detection, you can configure the replicas. Usually it is like a 3 factor. So this is how the Hadoop will move. I mean, HDF architecture will move. So internally to process all the data, like I said, like the name node will know the metadata, and the data node knows the actual data. So internally, we will have a MapReduce concept, which is written in Java. So what it will process all the data. Like we have the concept like mapper, we have the concept like reducer, we have the concept like combiner, and we have the concept of partitioner. We will explain each and every module in detail when we go deeper into the courses. So if you want more about HDFS, so by using this, we have advantages like the scalability, and we have the data availability, I mean high availability and distributed. So these are all the concepts which we discussed. Like the high availability in the sense, even if something fails, still we have the data to process. So that is the assurance which Hadoop HDFS can give. So this distributed file system is like to store the large files and store the files as large blocks. Like in our example, I said like our 100 MB is block data file is divided into 3 blocks. Each block is size of 30 MB. But in Hadoop, by default, it is like 128 MB. And the remaining, like if you want to configure it for more, you can configure it. You have the options to configure. And each block stored on multiple servers. It's also been covered in the what I said. Like the block will be stored in different nodes. Data is automatically replicated on it. Like it has a mechanism to MapReduce program on the configurations. So this is all about. And again, if you want to go through, you can go through this block. What is in the block? It's like file system. The actual file will be split into small parts. And we correlate to the example I said. The employee file will be split into equal number of parts. And each part of the file is called a block. So default it is 64 MB. Now it is configured like 128 in the present architecture. So Hadoop, it is when it comes to the market, it is an open source system, and it has 2 versions. One is like Hadoop 1.0, and next version is Hadoop 2.0. So 1.0 version we have demands like a name node, a data node. We have a job tracker. We have a task tracker. Demands are jobs like that. So it has what the name, we discussed about the name node, and we discussed what is a data node. We have to discuss about a job tracker. So what it will do is, a job tracker responsibility is to allocate the resources to a particular job and to start the particular job. Let's say a particular job is required this much of memory and this much of processor. So the job tracker will does all those things, which will take the reference from the metadata in the node. So the another one is task tracker. The task tracker is like the place where the data will be executed. Like it will be at each task tracker will be presented in the data node. So in each data node you will have one task tracker. So it will receive the request from the job tracker, and it will execute the particular amount of job on particular data node. And all task trackers will give information result back to the job tracker, and job tracker will pass the information and return back to the client. This is how the flow will go in Hadoop architecture 1.0. So we have some disadvantages in Hadoop 1.0 or some limitations, you can say. And due to this, we are now into Hadoop 2.x. In latest version, the job tracker is replaced with application master, and you have like node manager, job manager. Few components has been introduced. We will discuss each and everything in detail later going into the course. So this is how the replications will be. So this is the name node, this is the file name, this is the number of replicas, and each block IDs. And you will be having the path where the data is stored. So like that, the syntax will be. So the data node here is, it stores as actual data and it processes the actual data. It updates the name node regarding the progress of the processing. So what I said, it keeps on giving the results back to the job tracker about its execution by using the task. So the name node which we discussed, it stores the metadata like which block stored and which. So what are the requests we got from the client? It is like if you want to store the data, or if you want to retrieve the data, if you want to do something analysis on data, everything will be dealt by. We have the concept of called name node and as well as secondary and primary name node. Secondary name node is like backup of the primary name node. If something happens to the primary name node, the secondary name node will come into picture. So it has its own advantages, and we will cover all the. So if you have more questions from you,
I don't have any questions.
good. It's from it's